Okay, good morning, everyone. So tomorrow is your holiday, academic off, okay, because of Gandhi Jayanti. So okay, okay. So we were doing chapter 8, introduction to 4G, and in earlier session we had seen that 4G depends on long-term evaluation or voice over long-term evaluation. It is basically wireless communication standard, gives you high-speed data for mobile phone as well as for data terminals. It is based on GSM Edge technology 2 and 2.5 and 3 and 3.5G network technology, and gives you very high-speed data. We also had covered up one simple technology of WiMAX, worldwide interoperability for microwave access. Uh, it is based broadband connection as well as wireless communication. It is it is both technology, having an IEEE standard of 802.16, and gives you three types of support in network. It gives you mobile network, fixed network, and nomadic network. Nomadic network is never going to be fixed. It's going to be continuous on a move. Then I also told you that it gives you 75 Mbps of speed with an LOS connection, and sometimes provide you Gbps in speed when you are having LOS connections. Based on something called as OFDM, as well as there is something called as multi-carrier modulation (MCM). Both technologies is behind this 4G technology. The bandwidth allocation is going to be similar, 5 to 20 megahertz, which was there in the 3G as well. This diagram of WiMAX is being drawn in the previous session. We had a WiMAX transmitter, and which is connected to the internet service provider, which provides you the service. And this ISP is indirectly connected to the distributed network, which is your internet. Then from this ISP, the connection has been gone to the access points, which we call as backhaul or backbone network. One antenna is connected to another, another one is connected to another one, which are in line of sight. So they all are in same direction. So they are having a very directional antennas. So they are having a very good speed, line of sight connection. That means high speed. From the last antenna from the backhaul network and to the home receiver, there is a non-line of sight, that is NLOS, and where we have a low speed. So all problems such as interference, noise, disturbance, attenuation, distortion, all things happens in this region. Other regions are quite, satisfied with the speed and all. But this arena is the research arena basically. So this is the problem. Okay, so this is the thing that we had discussed, and apart from that, we had taken something from you as well. So you had given me some introduction for 4G with several points, which we had discussed in the previous session. So in this session also, we will do the same thing. I'm going to give you the next topic, which is features and challenges of 4G. So I'm going to cover that up, and then we will take one by one. Student give me the points for the feature and challenges. All right. So I think we'll do the same thing again. So I'm going to cover the feature of 4th generation. What could be the features? Uh, So in this chapter, the best topic is the network architecture, which is a very lengthy topic, which I'm going to cover up. I think maybe in the next, in the next week. So the first feature of a 4G connection is we already, written it down here in the introduction, but still for the features we're gonna write. So it supports something called as multimedia, it support voice, video, wireless internet, and other broadband services. So for this is the first feature I'm gonna put it over here. This is support interactive multimedia, voice, video, wireless internet, and other broadband services. This is the first feature. The second feature is the high speed, high capacity, and low cost per bit. You see, the cost for the end users are going to be very low. However, for the cost of those who are handling the network is going to be very high because they are using too much of hardware in the 4G connection. So there are high equalizers. If you had seen equalizers, they are basically the battery power backup. There's so many things which come exist in between you and your network owner. All right, so the cost for them it's very high. However, the cost for you it's reliably small and compared to the owner. Right? So that's why we have low cost per bit. Uh, then another thing that from the perspective of a cellular network, it gives you the mobility and portability also. So you can also use 4G connection on your handheld devices such as mobile, laptop, tablet, or palm top, or likewise. Right. So it provides you the global mobility, service portability, scalable mobile network. Okay, so because it gives you so much of portability, then this kind of 4G connection is going to be scalable. I mean, it is shared with a large audience, large mass, and that's why you can see that number of users are using 4G connection on their mobile phone, and the rate at which the this connection, this 4G connection, get into the mobile phone is comparably lower. I mean, it's higher than that of the network connection used in the fixed computers. Okay, आप 4G connection को mobile और ऐसे small handheld devices पे ज़्यादा use करते हैं comparably with the fixed computers. So that is also good advantage for the cellular networks. So next thing is in the feature itself. So we have a seamless switching technique. So earlier we had, I think, question from someone from this class that what kind of this switching they are used in 4G. 4G uses basically packet switching. I'm confused with the virtual switching, but I mean, they are using packet switching. Okay, so I'm sure about it right now. So it's packet switching. So seamless switching and a variety of services based on QoS requirement. You see that whenever a new network comes up, it doesn't have to think much more about the technology because they are using the same technology as there in the previous one, right? But they are just modifying the technology for a for a reliability or for kind of good service to the end users. So they generally work on QoS, quality of service. They do not work on hardware or any kind of other technology, but they precisely work on QoS, quality of service. So that comparably use for like reduction in the noise, reduction in the bit error rate, reduction in the interference, those kind of things. So 4G is also the same thing. It is having the same old technology by some modification they have named as OFDM and MCM and such as, but it's the same old technology. They are working on this QoS, which is this problem arena which I had told you earlier. This they are using this quality of service requirement here in this region because this region is a kind of research arena for people who are working in network. This region is not a good here. It's really a problematic part for the end user. Till now, it's a good network. I mean, if you are sitting over here in between this line of sight connection, you will get a very good connection. You can download like on a very huge speed. But however, this is, I mean, you will definitely get a good speed, but varied speed you will get. sometimes it is very large, sometimes it is very low, something like that. So they are working on quality of service. It is a requirement for them. And the last one is not last one, but it also gives something like scheduling time and the call admission control. If you had seen this scheduling, what do you mean by scheduling is based on access control and call admission control technique. You see that by means of access control, it means there is only a single channel, and on that single channel, maybe 10 stations rely on it, right? So they are fighting for to access that channel. So whenever a station see that or assume that the channel is free, they're gonna grab it, okay? To provide the service to the end users. So because of that reason, 10 channels are trying to do, trying to grab that channel. So it is very necessary that you provide some good scheduling algorithm there, so that one after the other and another after the other channel can access it. Otherwise what will happen, they're gonna congested the whole thing. एक स्टेशन आएगा, चैनल को पकड़ेगा, उसी टाइम पे दूसरा स्टेशन भी आएगा, चैनल को ग्रैब करने की कोशिश करेगा. सो इन दोनों सिचुएशन में क्या होगा कि कंजेशन हैपन और समथिंग लाइक जैमिंग हैपेंस. So we need some better admission control, better scheduling algorithm, so that we can schedule these station कि भाई ये टाइम पे तुमको चैनल एक्सेस करनी है, इसके बाद तुम्हारा चांस है, इसके बाद तुम्हारा चांस है, इसके बाद तुम्हारा चांस है, likewise. Okay, so this is better scheduling and call admission control. Actually, when I say admission control techniques, there are many actually. So we cannot take all these things because it is done in the elementary network in your, I think, 5th semester. If you want, you can have a look on the computer network book. You will get it from the chapter, I guess, this data link layer. We have a MAC, media access control, where you can find this admission control techniques. All right. Then this 4G technology is also having a feature related to the personal network, okay, the wireless personal network. So it also supports wireless personal area network. We call such network as VPAN, such as uh, VPAN and ad hoc network. Okay, such as you can say Bluetooth. There is a hyperLAN. See, I do not know much more about hyperLAN. It's not necessary here also, but it's a wireless personal area network specifically for your service. Then we can also use 802.11b, which is a Wi-Fi connection with a good speed. Um, so, so it also supports these kind of network. And also we can say that wireless personal area network, ad hoc network, and multi-hop network, which are the same thing. Network. And multi-home. Okay, so these are the I think 6 features of 4G. Now you tell me, do you have anything that you're having any problem? And tell me in this 6 points. Any doubt in this 6 point? Okay. Mm, so let me take one more topic, which is the comparison of 3G and 4G, which is also very important when we are dealing with such technology, that we can compare the earlier technology. So comparison of third generation and fourth generation to this. So how can I compare it? I'm going to take 3 columns here. The comparison is based on like third generation and fourth generation. Be on the middle part. And this is like what you can say, it's a characteristic, not characteristic, but parameters, let me say. So the first parameter on which I can compare third generation and fourth generation is the frequency band. Frequency band, and by the way, this is the heading, so it should be bold. So what frequency band third generation used is 1.8 to 2.5 gigahertz. It was used by your third generation. Your fourth generation is specifically work on a little bit higher than that, so it is 2.8 gigahertz, and not in the range of this third generation. By the way, you see that sometimes your fourth generation connection is working on third generation comparison when you get lower speed. They are working parallelly actually. There is no separate fourth generation, so sometimes you are getting a very low speed, then your connection get automatically into the third generation. It completely depends on the configuration, how configure you had set your network. The next parameter is based on bandwidth, and as I told you that bandwidth is not being changed. That is again on the same 5 to 20 megahertz band. So I'm gonna say this is 5 to 20 megahertz band. Again 5 to 20 megahertz. Uh, Data rates are they are quite similar, but very slight change here that it up to ranges to up to 2 mbps, and this sometimes gets to uh, 20 mbps and more. This is quite, you can, as I told you, that it reaches to 75 Mbps. That's the highest speed that WiMAX can get into. So it's 20 Mbps for other technology. Maybe it's a Wi-Fi, okay? Wi-Fi, which is using fourth generation, you can reach up to 20 Mbps. However, if you use WiMAX, then it reaches to 75 Mbps. It completely depends on the application that you are using, right? The next parameter I can take is access. So the channel access that I'm going to take. So earlier 3G connection is uses wideband CDMA, that is code division multiple access, to access the channel. However, the fourth generation, as I told you, it uses something called as multi-carrier CDMA, which is MCM connection. So this is a multi-carrier modulation. It's known as MCM, known as OFDM or OFDMA. Yeah, same thing. So multi-carrier modulation also deals with MIMO. It again the excess thing, see antenna diversity, which you generally call. So if you remember your multi-carrier modulation, we had also seen this in the previous session. I think in the first or second chapter. If you remember, I had given you 3 or 4 names in the MCM or multi-carrier modulation, which are, first one is MIMO, second one is so, third one is SIMO, fourth one is so. Okay, so these are multi-carrier modulation that we had seen. So this MIMO says uh, there should be multiple input. So there are multiple antennas and multiple. Okay, so at the both end, at the sender and receiver, at the both end, you're gonna have multiple antennas and multiple output antennas. However, in the MISO, there is going to be multiple inputs, यानी कि multiple antennas होंगे, लेकिन single output होगा, single receiver होगा. सिमो में है आपके पास सिंगल इनपुट है, यानी कि सिंगल एंटीना है, और आपके पास मल्टीपल रिसीवर होंगे. ओके टू बी हैव आउटपुट और रिसीवर बोथ. सिंगल इनपुट है आपके पास और यहाँ आपके पास सिंगल. So these are the antenna kind of thing which you had seen it. So ये आपका है जो ये मल्टी कैरियर मॉड्यूलेशन जैसा हम कहते हैं. So this is the thing. And by the way, this OFDN and OFDMA, we will see this thing, this particular technology. I have these notes. The full form is orthogonal frequency division multiplexing. This one, and this one is orthogonal frequency division multiple access. So this is a media access, यानी कि ये डेटा लिंक लेयर पे काम करता है, और ये मल्टीप्लेक्सिंग है, मतलब कि ये फर्स्ट यानी कि फिजिकल लेयर पे काम करता है. ओके, so multiplexing, if you remember, it works on physical layer, and multiple access works on data link layer, yani ki layer 2. Okay, so both are the things. Another thing, another parameter we cannot take it for the error control, forward error correction. If I say there are now you see third generation uses something called as turbo codes. They are I do not know whether you had done this Hemming code and uh, a convolutional code or block code or something like that. If you had done this, then these turbo codes are basically used to give redundancy in your data. And once you get large redundancy, you can find the errors quickly. Okay, हम जल्दी से जल्दी error को detect कर सकते हैं with the help of these turbo codes or any other code. There are actually plenty of codes available for error correction. Some of the best one is Reed-Solomon code and convolutional code. We also having this Hemming codes. So these codes are just to give redundancy in the data, and with the help of that redundancy, we can find the error. So by means of redundancy is, if you are having a 7-bit of data, then I will add 4 more bit. Okay, that 4 more bit is known as parity bits. So once you add that, the whole frame is going to have 11 bits. Okay, instead of 7, now I am sending 11 bits. So these 4 bits which I had appended in the data, they are going to use for the error control. Okay, so by that I can find the error quickly. If you want any kind of tutorial based on that, then uh, I had made it on YouTube, I guess. Okay, so the code available for 4G, we have something called as concatenated code. Concatenated, a very bad at spellings. So concatenated codes means it's not only the single code. So after a block of modulation, you can put one code, and then after another block, you can put another error control block. So it's something like you do not have the single block for detecting and correcting the errors, but you have multiple blocks of error correction and put it into the concatenation form. So when we see the block diagram of fourth generation, the network architecture, then at the time of that, I will show you one yeah, this forward error correction book, code. Okay, the name is convolutional code that we're gonna see in the later session. So when we are dealing with this fourth generation architecture, then switching. So you see that earlier in the third generation, we have circuit as well as packet switching. Both switching has been applied to the third generation. However, with the fourth generation, we only have packet switching. All right. So in general, this is basically the comparison for third generation and fourth generation with some parameters. I I think it's. I mean, it is easy. Or do you find any problem here? Any question in it? Any question? Okay. Okay, fine. So now you see we had covered up the features. There is a challenging part that I need to provide, the issues in the fourth generation. But before that, what I want here, I'm gonna put, if you are not listening my voice, then I'm putting the question here. give me some of, come on, some of the technology related to fourth generation, such as WiMAX. I already had covered that up. Find any technology of 4G and explain it in brief. Here is the question. If you if you're not listening my words, then please see this question. Review question. Clear with the question? What you need to do? You need to find a technology of fourth generation, such as WiMAX. I already had covered up. No issue if someone is taking WiMAX and explain it me in a better way. No issue in that. But you need to find a technology related to the fourth generation and then explain me the working, or maybe a kind of brief introduction of that technology. Clear with the question, everyone? Clear or not? Understand the task? No issue. I'll wait till 10. How much time you gonna need for this? Next lecture. Okay, so you need this much of time. No issue. So you take no issue. So 23 minutes. Okay, fine. So I'm gonna ask you this in the next lecture, as everyone is ready with that. The next lecture, I do not have any problem. So next lecture, you will be ready, right? So I hope I'm saying. I'm saying next lecture will be okay, right? Okay, son. Okay, then we're gonna see this in the next lecture. Uh, okay. So I need to take this in the part. Okay. Now we're gonna see some issues on the higher layer of fourth generation. Hmm. So what could be the issues? You see that the topic is the challenges of fourth generation, and or I can say the issue of issue in fourth generation. Okay. So the first issue here, Okay, so the first issue is based on mobility management. See, I'm going to cover the higher layer issues, not the lower layer issues. So remember, you can write your lower layer issues such as the cost and all. That will I definitely put it over here in the notes, but they are very self-explanatory. So I'm not gonna put it here. So mobility management is the first issue here, and how it deals with is. Is basically the problem in the cellular network is the handoff. And how many of you remember handoff or handover? Anyone? Anyone who remember handoff or handover? Okay, you see the handoff switching from one cell to another cell. Very good. So unit one topic. Yes, exactly. No, unit one. No, unit one. It is a topic of I think in the third chapter, the GSM, where we had seen handoff and handover. We also had seen four types of handover. So when a user moves from one cell to another cell, I'll show you to see. It's something like this. If you remember, there are two cells, something like this, and if these two cells are like this is like maybe Nanamova and this is like Madhapattu. So when you are moving from this location to this location, you are also changing your access points, right? So earlier you are connected to this. Now you are connected in Madhapur Chowk to this access point. So what you are doing here is basically this is a handover, all right? So you are changing. So whenever you move like this, or whenever you are changing the access point, it is known as handover. So the mobility management में सबसे बड़ी प्रॉब्लम हैंडओवर की आती है. क्यों? क्योंकि ये हैंडओवर इजी नहीं है. ये आपको लगता है कि आपको नेटवर्क मिल जाता है जैसे आप दूसरे लोकेशन पे जाते हो, ये इजी आपके लिए है. But to manage, okay, when we are dealing with managing things, it is very hard because disconnecting from here and connecting to here is like इन अ वेरी फ्रीक्वेंट ऑफ सेकंड्स में हो जाना चाहिए. तो ये हो जाने की जो प्रक्रिया है वो बहुत हार्ड है, राइट? और ये भी हो सकता है कि आप यहाँ पे स्थायी ना हो, यहाँ से भी कहीं फट से मूव हो गए हो. सो तुम देखो यहाँ पे फ्रीक्वेंट चेंजेस हो रहे हैं. अगर आप कार पे हो तो ये फ्रीक्वेंट चेंजेस बहुत जल्दी जल्दी होते हैं. आप कार से जा रहे हो, यहाँ माधापुर चौकड़ी पे रुके ही नहीं हो, सीधा कहीं निकल गए हो, अगेन आपको एक हैंड ओवर चाहिए. सो दिस इज वेरी हार्ड फॉर फोर्थ जनरेशन बिकॉज एक तो ये इतना कॉम्प्लेक्स है, ऊपर से आप ये मोबिलिटी मैनेजमेंट जैसी चीज डाल रहे हो उसमें. So it takes very uh, it is having a very complex nature here, right? So that's why there is a problem, there is a challenge in the mobility management. It says the here, this includes क्या क्या चीजें includes करता है. It includes location registration. So when you are at a location, you need to register with your HLR. Also, you need to do something like sometimes you need paging. However, this is not being used now. And handover. So as I told you, so MT should be so MT is a mobile station. So I'm gonna write the MS. MS should be able to access the service at any possible place. ओके, आपका मोबाइल स्टेशन को हमेशा कोई ना कोई नेटवर्क सर्विस चाहिए, चाहे वो किसी भी प्लेस पे हो, वंचित नहीं रह सकता नेटवर्क सर्विस से. सो ये चीज कैसे हो सकती है हैंड ऑफ से. सो द हैंड ऑफ टेक्निक should be designed so that they make efficient use of network and make sure that handoff are not done that often. Okay, so अगर आप ये कर भी रहे हो तो 4G आपको कहता है कि आप ये ज्यादा ना करो। क्यों? ये क्यों नहीं करने देगा? क्योंकि फोर्थ जनरेशन में हमने क्या कर दिया है, ये जो एक्सेस पॉइंट है आपका, ये जो एक्सेस पॉइंट है, इसकी जो सिग्नल स्ट्रेंथ होती है, जैसे हम बोलते हैं RSSI, रेडियो सिग्नल स्ट्रेंथ इंडिकेटर, ये हमने लार्ज करके रखी हुई है। सो इफ द रेडियो सिग्नल स्ट्रेंथ इज लार्ज, देन इट कवर्स अप this cell and the other cells. So if the signals are very large in range, then even if you are in the second cell or in the third cell, you can still be connected to this access point and not this one. So fourth generation आपको ये करने देता है, लेकिन वो आपको साथ साथ में ये भी कह रहा है कि अगर ये सिग्नल आपको नहीं मिल रहे हैं तो आप इस एक्सेस पॉइंट के साथ कनेक्ट हो सकते हो, हैंड ओवर कर सकते हो, लेकिन आप ज्यादा ना करो। ओके, ऐसी स्थिति बनाओ आपके मैनेजमेंट, आपके सेलुलर नेटवर्क में कि आप ये ज्यादा ना कर सको। इसलिए ये एक्सेस पॉइंट की सिग्नल स्ट्रेंथ जो है ये ज्यादा करके रखी हुई, इसलिए आपको डेटा स्पीड भी ज्यादा मिलती है, राइट? सो दिस इज द फर्स्ट चैलेंज, this handoff and handover. Do you have any problem in the first challenge, the first issue? Okay. Second is something called as congestion control, which is always going to be there. So uh, हम बोलेंगे CC. See that congestion issue is basically, it's a critical issue to get a higher performance for fourth generation. And how we can basically resolve this congestion control. Okay, my voice is not clear. Uh, Anyone also facing the same issue? My voice is not clear. कोई और को भी प्रॉब्लम आ रही है वॉइस में? I think because maybe your network is slow or so. तुमको कहाँ से समझ नहीं आया विकास? I can repeat it. हाँ, so I just had started. Okay. So congestion control जो है वो बहुत बड़ी प्रॉब्लम है फोर्थ जनरेशन में भी, जो कि हमने पहले भी देखी थी। सो इसको ठीक करने के लिए ये दो अप्रोच लेता है। अगर आपको मालूम हो तो दो अप्रोच कुछ ऐसे हैं डेटा लिंक लेयर से, कि एक तो वो अवॉइड कर सकता है और प्रिवेंट कर सकता है कंजेशन से। दूसरा, अगर वो वायर्ड कनेक्शन पे है तो डिटेक्ट कर सकता है कंजेशन को और रिकवर कर सकता है। सो द थिंग इज लाइक दिस, सो देयर आर टू अप्रोचेस, there are two approaches based on the connection you are using. So if you are using wired connection, then you know that it is based on like detection and recovery after the congestion. Before तो कर नहीं सकता। दूसरा, अगर आपके पास वायरलेस कनेक्शन है, then you can do something like वायरलेस में आप डिटेक्ट नहीं कर सकते, बिकॉज एयर इज अ मीडियम, एयर में कहाँ ढूंढने जाओगे प्रॉब्लम, राइट? सो यू कैन डू लाइक अवॉइडेंस एंड प्रिवेंशन ऑफ कंजेशन। सो ये जो चीजें हैं, अगेन इसको कंट्रोल करने का के लिए कई सारी चीजें हैं जो फोर्थ जनरेशन को करनी पड़ती है, विच इज अ काइंड ऑफ चैलेंज फॉर हिम। सो अगर हम बात करें अवॉइडेंस की, सो ही नीड्स टू, दिस थिंग नीड्स टू डू समथिंग लाइक शेड्यूलिंग टेक्निक्स अच्छी बनानी पड़ेगी। हमने पहले बात करी थी शेड्यूलिंग टेक्निक्स, दैट मींस एलोकेशन टाइम ऑफ स्टेशन, कि भाई 10 मिनट में इस स्टेशन को देता हूँ, 10 मिनट में आप अपना ट्रांसमिशन और रिसीविंग खत्म करो, फिर 10 मिनट में फिर दूसरे स्टेशन को दूंगा, आप अपना ट्रांसमिशन रिसीविंग खत्म करो। लाइकवाइज हमको ये शेड्यूलिंग अच्छे से बनाना पड़ेगा। और अगर हम बात करें वायर्ड कनेक्शन की, जहां पर हमको डिटेक्शन और रिकवरी में काम करना पड़ता है, देन दिस थिंग नीड्स टू हैव better flow control mechanism. Okay, and I hope a flow control is very clear to you. So flow control हमने देख लिया था। तो ये दो चीज कंजेशन कंट्रोल में उसको करनी पड़ती है अकॉर्डिंग टू योर कनेक्शन। दैट अगर वायर्ड कनेक्शन है तो आप जल्दी से जल्दी कंजेशन को डिटेक्ट करो और उसको रिकवर करो, राइट। और अगर वायरलेस कनेक्शन है तो डिटेक्ट नहीं हो सकता है तो एटलीस्ट उसको अवॉइड करो या प्रिवेंट करो। सो अगर अवॉइड और प्रिवेंट करना है तो आप क्या कर सकते हो, बेटर शेड्यूलिंग एल्गोरिथम बना सकते हो कि भाई इस टाइम के लिए ये स्टेशन रिजर्व है, उसके बाद नया स्टेशन आएगा वो रिजर्व होगा, उसके बाद नया स्टेशन आएगा वो रिजर्व होगा। अगर हम वायर्ड की बात करें तो आपके पास फ्लो कंट्रोल सही होना चाहिए। सो सी, अगर आपने ध्यान से देखा हो, नेक्स्ट क्वेश्चन इज फ्लो कंट्रोल जो है आपका वो दो जगह आता है, एक आता है डेटा लिंक लेयर पे और एक आता है आपका ट्रांसपोर्ट लेयर पे। सो व्हाट इज द डिफरेंस बिटवीन दीज टू? Okay, no issue. Okay, so we're gonna take the third problem of fourth generation. It is multi-access interface and timing and recovery. So multi-access interface means, the same connection is going to be interfaced by many devices, such as your mobile phone, tablets, लैपटॉप, फिक्स्ड कंप्यूटर, आप सब जगह उस इंटरफेस, आई मीन सब जगह अलग अलग इंटरफेस से सेम कनेक्शन यूज कर सकते हो। सो अब ये जो यूज करने की प्रक्रिया है, यानी कि मल्टीपल डिवाइस को हैंडल करने की जो प्रक्रिया है, ये भी एक किस्म का चैलेंज है फोर्थ जनरेशन के लिए। दूसरा प्रॉब्लम सिंक्रोनाइजेशन का है, सिंक्रोनाइजेशन यानी कि टाइमिंग। सो बिटवीन योर ट्रांसमीटर एंड रिसीविंग द सेम सिंक्रोनाइजेशन नीड्स। सो अगर वो नहीं है तो अगेन प्रॉब्लम, right? So this is a kind of challenge for the fourth generation. The another challenge is the complexity. How complexity? Because fourth generation is itself is a very complex thing, right? See, error control में problem है पहले, क्योंकि ये हैंडल करना इजी नहीं है फोर्थ जनरेशन के लिए। दूसरा, डिजिटल टू एनालॉग कन्वर्जन जो है, डिजिटल टू एनालॉग कन्वर्जन जो है, ये बहुत हार्ड है फोर्थ जनरेशन के लिए करना। इट्स अगेन नॉट अ वेरी सिंपल टास्क। सो अगर आपको ये डिजिटल जो एनालॉग करना आता हो, अगर आपने पल्स कोड मॉड्यूलेशन पढ़ा हुआ पीसीएम, तो उसके अंदर इसकी टेक्निक दी गई है। कभी आप डिजिटल कम्युनिकेशन की बुक ओपन करना, आपको दिखेगा पीसीएम। तो ये जो प्रक्रिया जो पहले यूज होती थी 2.5 3 जनरेशन में, वो बहुत इजी थी। You just need a sampling and quantization, and there you go, digital to analog, done. However, with this fourth generation, it is really very hard. So this is again a complex. इसका जो मैथमेटिक है, ये करने का जो इसका सिग्नल प्रोसेसिंग का मैथमेटिक्स है, वो बहुत हार्ड है। It needs calculus differentiation, very hard calculus, very hard differentiation. So that's why it is again a complex problem for fourth generation. I'll show you the mathematics also while we doing OFDM. तब आप देखना उसको कि कैसा लगेगा आपको। The next thing is issue with the other network. Issue with other network. So it also support, as I told you, ad hoc network, personal area network. But then there is a problem such as ad hoc network के साथ इसका अच्छा नहीं बनता है, ये इतना स्टेबल नहीं है उनके साथ। ब्लूटूथ के साथ भी स्टेबल नहीं है। Then 2.11b के साथ भी स्टेबल नहीं है। Then third is, as we are dealing with a wireless communication, then you see, then security is always going to be a problem for us. So security. So these are some of the challenges, the normal lower end challenges, and these are the higher end challenges. So are you facing any problem and challenges of fourth generation? Clear to all or not? Okay. Uh, Thank you. So we had done the feature challenges of fourth generation. Fine, 1667 Parth,
Yes, sir.
17.1, 17.6, 17.8.
Yes, sir. 1.
6.
Yes, sir.
Okay, 8. Mansi had, I think, given me the attendance here. 79, Heth. Okay, 17, 12. 17, 17. Lata has also given. Okay, okay, you had given me the attendance in mail. Komal,
Yes,
17,
sir.
18. 17, 19.
Yes, sir.
17, 26. 17, 33. 17, 30. Okay, okay. 17, 34.
Yes, sir.
Okay. 17, 37.
Yes, sir.
41. Okay. 45. 48.
Yes, sir.
49. 60. 62. 63.
Sir, 60 present.
60 present. Okay. 66. Okay. 67. 69. 72. 72. Okay. 73.
Present, sir.
74. 76. Null. 77.
Present, sir. 77.
Okay, fine. 79. Okay, 80.
Yes, sir. 80.
Okay, 82. 85. Okay, 86. 87. Okay, 91. 100.
Present 100.
Okay, fine. 107. 108. 109. Sorry, 112. Vicky Kumar is not here. 113. Okay, 114. 119. Okay, 120. 121. 124. 126. 127.
Yes, sir.
Okay, 129. 130. 134. 135. 136. 145. 164. Okay, 190. 100. Sorry, 05005. Mehul. Lokesh is 135. All right. 005 is not here. 010. 016. Sagar. I think he had given me the attendance. Yeah, yeah,
Yes,
done.
sir.
001. 19. Haley.
Hello, sir. Sir, I cannot write in a chat box.
Yeah, Maulik,